returns the question 3. I think I did send the video for question 3, so I'll go straight to question 4. The difference is only on 3.1 on that definition, and that was 2024 Eastern Cape. So this one is Limpopo 2025. Okay, so question 4. Now this is the motions. A motor car which is 100 meter behind the truck. So the distance there, the distance is 100 meter. Both the vehicles are traveling the same direction at 72 kilometer per hour. So okay, 72 kilometer per hour. Remember, in our calculations, you need to convert it to meter per second. So how do you convert that one? So it will be 72 kilometer then per hour. So we know 1 kilometer is equal to 1,000 meters. So then the hours, we start with the seconds. 60 seconds is 1 min. So 60 min, so it will be 1 hour. So I'm having 60 multiplied by 60 there. So that will be 72,000 meters divided by 3,600 seconds. So once you calculate that, you're going to get the 20, it should be 20 meter per second. 20 meter per second. All right. So the easy way or another way is to divide by 7,2. So that's 72 kilometer per hour. Per hour, you just divided by 3,6. Then still we're going to get 20 meter per second. All right. So there are two ways of doing this. So we know this car is traveling at 20 meters per second. Even the truck is traveling at 20 meters per second. So now the truck drivers over the landmine, which explode, causing it to stop at that point. So talk about the explosives. So it makes it to stop at that point. The driver of the motor car takes 0.4 seconds before he applies the car's brakes. So now it takes 0.4 seconds before he applies the car's brakes. Once the brakes are applied, the car slows down uniformly at 2.5 meter per second squared. So this is acceleration slowing down. We're expecting this acceleration will be decelerating, actually negative, because it's moving down. Okay, explain the term slows down uniformly at 2.5 meter per second squared. So how do you explain that one? So it simply means this acceleration, remember, this is question I will be having question 4. Now the acceleration 4.1, acceleration is the rate of change in velocity. Acceleration is the rate of change in velocity. So to get this velocity, to get that acceleration of 2.5, it simply means I'm having this scenario. So the velocity decreases by 2.5 meter per second. So you're going to say now 4.1 velocity decreases, by 2.5 meter per second for every second. So this is the meaning of that. So velocity decreases by 2.5 meter per second for every second. So this is how we're going to answer this question there. Okay. Then now let's look at 4.2. Now show that the 72 kilometer per hour is equals to 20 meter per second. We have already done that part. We have already done that part at the top there. We have done this part here. So this is one of the option, or it can be this option 2. So that will be 2 marks for this. So it will be 2 marks for that. Okay. Then we're going to say 72. Let me do this. 72 divided by 3.6, we get 20 meters per second. All right. So then 4.3. So 4.3. Now determine the distance traveled by the motor car during the 0.4 seconds reaction time. So 0.4 seconds the reaction time. So what you're going to do now, you want to determine the distance. So you know you're going to say for this one, it's traveling at 20 meter per second. The velocity, rate of change in position, divided by this. So what I'm having the velocity there. The velocity is 20. Then now the distance delta x, the reaction time 0.4. Then you say cross multiple. So our delta x will be 20 multiplied by 0.4. You get 8 meters. Okay. So this is one of the options that you can use. Or now we have equations of motions. There's this one, delta x. Let me do this. I'm still having a space here. I'm going to say or the delta x is equals to v I delta t plus half a delta t squared. So now the velocity. So remember, this kite moves at constant velocity of 20 meter per second. Is 20 multiplied by the reaction time, which is 0.4 plus half. So what's an acceleration? The object moves, let me see, the 72 kilometer per hour. So it moves at 20 kilometer per second. Now that must say it's traveling. Oh, there's at the top there, the same direction at 72 kilometer per hour, which is 20 meter per second. So now uniformly simply means it's a constant velocity. Acceleration will be 0 there. So this is 0.4 squared. Ultimately we're going to get 8 meters. Yes, 8 meters. Okay. Now another option that we can use, we're having the delta x is equals to v final plus v initial all over 2, then multiply by delta t. The constant velocity v initial and v final are the same. then the reaction time is 0.4. So it will be 40 divided by 2 multiplied by 0.4. Then you're going to get same answer, which is 8 meters. Okay, then now we know that will be 3 marks, one of the option. You can choose one of the options there. Then what about 4.4? Now calculate the total time taken for the motor car to come to rest. Come to rest, finally, I'm going to stop. The final velocity will be 0. So now calculate the total time taken for the motor car. So now I'm going to say, okay, from the what? From the instant the driver saw lineman exploding. So now what I'm going to do, I'm going to just to say 4.4, the V final is equals to V initial plus A delta T. Now final is going to stop. V initial, it was moving at 20 meter per second. Because it's slowing down, acceleration is 2.5. Then now the delta T, I want to calculate delta T. This is minus 20 is equals to negative 2.5 delta T. I divide by negative 2.5 by negative 2.5. So the delta T, for delta T, now I'm getting 8 seconds. The total time that will be covered, the total time that will be covered, delta T, which is total. Remember, there's a reaction time of what? The reaction time of 0.4. Together with this one, once the object come to rest, finally is going to stop. After how many seconds? After 8 seconds. So the total time will be 8.4 seconds. Okay. So finally it's going to stop. It must be 0. Choosing this equation of motion, because acceleration is negative, then now you get your full 4 marks. That was 4.4. Then 4.5. This is the last question. So now, will the motor car stop before reaching the wreck of the truck? Show all working in your answers. 5 marks. So remember, there's a distance which is 100 meters there. So we need to check how much distance will be covered by this motor car. All right. We can use this equation of motion, V squared final, V squared initial plus 2A delta X. We want the distance because finally it will come to the end, it's going to stop. But initially this car was moving at the 20 meter per second, then it's experiencing a negative acceleration because it's uniformly slowing down. The delta X, then now ultimately we are going to square this 20, then we transpose it to be that side. Let's try to do it. Okay, that will be 20 squared is 400. It will be negative 400. Then you multiply these two. Then 2 multiplied by this is minus 5 delta x. I will divide by minus 5. Minus 5. Then now delta x will give me a distance of 80 meters. Then now remember, from 4.3, we determine the distance traveled by the motor car during the what? 0.4 seconds, which is the reaction time. The distance was 8 meters. So, yes, of course, if you look at this one, if you say the total distance that will be covered there, the total distance will be what? It will be 8 meter plus the one that we calculated there, which is 8 meter. So more or less you can see now moving 80 plus 8. So I'm going to have 88 meters. And remember, the distance should be 100 meters. Of course, the car will able to stop. The car will be able to stop. So now we answered the question. The car will be able to stop because now it will cover 88 meter once we add that 8 meter which was calculated in 4.3. So by having the formula there, and now we're having this, we can have the full 5 marks. We can have also other equations of motions to try to calculate this one. You can try for me, use this one just to calculate the delta x is equals to v I delta t plus half a delta t squared. I'm going to give you just 2 minutes, try this one. Okay. All right. So now v initial is 20. What is our time? The time it took how many seconds? That was 8 seconds. Remember, we have calculated 4.4, the total time there. The total time was 4 seconds. Not 4 seconds, Harumi. The total time was 8 seconds. The total time, actually, the time that was covered was 8 seconds, but totally we added with the reaction time of 0.4 seconds. But you can just use this one of 8 seconds. If you want to use 8.4 seconds, you're going to get 88 meter. If you use 8.4, you're going to get 88 meter. But if I'm using this one of 8 seconds, then now I know the acceleration will be negative 2.5. So negative 2.5, then 8 squared, then we get the 8 meter. We can try by using the same formula there, 20 by 8.4 plus half negative 2.5, and now we use 8.4, then squared. I think it will be 88 meter because I've already added that 8 meters to get 88. But now, if we're using strictly 8 meters, you're going to get not 8 meters, 8 seconds. So 8 seconds. So you're going to get 80 meters. But if you're using 8.4 seconds, you're going to get 88 meters, which will be the same as that one at the top there. Okay, thank you very much.